Now that you have a general idea of how levels are used, let's learn how to implement some levels in our code. Make sure you've closed out of your exercise code and you don't have any source code files open. Together, let's now open up our lab master source code file. Just like button events and channel events, level events also have embedded properties that we need to understand how to properly use. From Netlink's Keywords Help, search for level events, and you'll see the list of embedded properties. Most of these properties look very similar to the other event properties we've already seen, but one in particular is most commonly used in level events. The one I'm referring to is level.value. So let's see it in action. Let's open up our touch panel file and launch our main page. Remember, earlier on in this course, when we first developed this touch panel, we had you create a bar graph at the top of the page for volume control. We're going to use this volume bar graph to control the volume of our DVX presentation switcher. Click on this bar graph and let's look at its programming properties. Back when we created it, we decided not to assign a level port or level code. Well, now that we understand the difference between ports and codes, let's assign it. I'll use level port 1, and I'll choose a unique code. Well, I only have one bar graph on my touch panel right now, so let's keep it simple and give it a code of 1 as well. And just to review, the level function is set to drag rather than active, so we don't blow out our speakers if we accidentally touch the bar graph someplace on the high end of the scale. And we'll keep the range set at 0 to 100, because that's the range that the DVX uses for its volume. Let's save and close our touch panel file. First things first, are there any devices we need to define? Well, since we chose to use port 1 on the touch panel, that's already been defined right here, DVTP. Our goal is to have the bar graph control the volume of the DVX. But what device should we define for the DVX? To begin with, we definitely know the device number is 5002. Refresh the online tree. If you remember, a DVX has 3 devices built into it. The master is always 0, the controller is 5001, and the switcher is 5002. Well, controlling the volume definitely falls into the switcher category. But what about the port number? Let's open up PI2. I need to find the proper command definition for controlling the audio output. Chances are, that'll tell me what port number I need to use. Select Command Definitions, Hybrid Switching and Control, All-in-One Presentation Switchers, and the DVX 3255. In the list at the top of the page, which one do you think would relate to the volume output level of the switcher? Netlink's levels, of course. Select that and it'll jump down to the Levels section. There's the list of all the levels that are available in the DVX. Wow, that's a lot of levels. It's broken up into 4 columns. The first one being the level number. So for example, if you wanted to adjust the video output brightness, you would send a value to level number 20. The next column is the port number. This is the information we're after. We're controlling the output volume, the first one in this list. Can you figure out why there are 4 port numbers? Well, take a look at the back of our DVX. There are 4 audio outputs. The main amplified audio output is 1, and 2, 3, and 4 are line level audio outputs. Hence, 4 different ports. The third column is the range of the level. Remember, we set our bar graph on our touch panel to match the range of this level, 0 through 100. Okay, let's go back to our Define Device section and finish defining our device. I'll call it DVX_odd_out1. Its device number is 5002, its port number is going to be 1, and the system number is 0. I'll scroll all the way down to the bottom of my Define Events section. Programming levels is one of the easier events to program. Again, we want to have the bar graph adjust the level of main audio output in our DVX. We start by creating a level event. Where does the level event occur? On DVTP. And the level code we used for our bar graph was 1. Open up a set of curly braces. The command to send the incoming level value to the DVX is send level, then the device to which we are sending this level. In this case, DVX odd out 1, followed by a comma, then the level number, which is 1. Remember back in PI2, the level number was in the first column. Then another comma, followed by the embedded property level.value. That's all there is to it. Now, when I adjust the bar graph on the touch panel, it sends the new value to the DVX to adjust the volume. Let's compile to make sure we didn't make any mistakes. This looks perfect. We have one thing left to do. As of right now, if someone adjusts the bar graph on the touch panel, the volume level of the DVX will adjust. But what if someone were to adjust the level of the DVX from the web interface or the front panel? The volume would adjust, but the bar graph on the touch panel wouldn't move. Thus, it won't represent the true volume of the DVX. See if you can write the code necessary to fix this. Pause this tutorial while you give it a shot. Okay, how'd you do? Let me show you what this would look like. I'll copy the entire level event. I simply need to change two things. First, the level event is now being triggered by the DVX. I'll change the device to DVX odd out 1. Next, the send level command needs to go to the touch panel. I'll change its device to DVTP. That's really all there is to it. However, these two small blocks of code provide me a perfect opportunity to teach you one other thing. Remember back in the variables lesson, we kept mentioning global variables? We briefly mentioned another type of variable, and that was a local variable. A local scope variable is a type of variable that can be defined directly inside of an event. There are two different types of local scope variables, local var and stack var. The first point to make about these variables is that their scope is limited to the block of code in which they are defined. The difference between them is in how long the value is left in that variable. Any variable which is defined as a stack var ceases to exist once you are outside the block of code in which it was defined. In other words, the memory location set aside for a stack var is immediately returned back to the stack of available memory, thus the term stack var. Therefore, you should consider it a temporary variable. Another thing about stack vars is that you cannot reference these inside a wait or debug them. A local var's value is initialized the first time the event is run, and it will maintain its value even after the event is complete. One trick to using local vars is that their time to live is indeterminate, so you never know how long that value will be held inside that memory location. Netlink decides when it needs that block of memory and overwrites it. Back to our level events. Just like the global variables, you could store level.value in a local variable as soon as the event occurs. Therefore, let's create a variable to store our level value. For the first one, I'll create a local var, because we want the ability to debug our code and view the incoming value. Remember, we cannot debug the embedded properties like level.value. The range of my level is 0 through 100. The data type to use is an integer, and I'll name it nValue. It's important to note, all local variables must be declared at the very beginning of the event handler. If you need to use a local var or a stack var, make sure that's the first thing you do before writing any other code. I'll make the assignment. nValue gets level.value. Now, all we need to do is change our send level. Instead of sending level.value, let's send nValue. Compile once again. For the second one, I'll create a stack var. If you do this, you won't be able to view the value in the watch bar of debug. And I don't care if the variable is destroyed after I use it, and I definitely don't need to use it outside of my level event. While I'm demonstrating both types of local scope variables here, it's worth noting that the second example, the stack var, is not really necessary. If we don't need to debug it, why create a variable at all? I would simply send level.value. That's all there is to it. It compiles without any errors, and we can load this code into our DVX. Now, it doesn't matter who adjusts the volume, both the touch panel and the DVX will be in sync. Now it's time for you to try for yourself. Save and close this code file, and get ready for another exciting exercise.